Very good evening, everyone. We hope you are having a great time exploring the fascinating world of quantum computing and machine learning during this faculty development program on quantum machine learning, bridging the gap between quantum computing and AI. Welcome to day 3, session 5, where we will dive into a highly innovative topic, quantum gate model for the transport industry to optimize routes. This session will explore how quantum principles can revolutionize transportation by optimizing routes, improving efficiency, and addressing real world challenges in logistics and mobility. Our esteemed speaker for this session is Dr. Kumar Gautam. Dr. Kumar Gautam is an associate professor at Vivekananda Institute of Professional Studies. Dr. Gautam is the founder and president of QRace and director of eGreen Quanta LLP. He holds a postdoctoral research position at GIST South Korea, where he focuses on the quantum vehicle routing problem. Dr. Gautam earned his PhD from Delhi University, specializing in quantum gate design based on Schrodinger dynamics. With over 8 years of teaching experience, Dr. Gautam is proficient in MATLAB, quantum computation, Python, and quantum stochastic differential equations. He serves as a regional mentor of change under the ATAL Innovation Mission, Niti Aayog, Government of India, where he promotes innovation and entrepreneurship among students. An active member of the academic and professional community, Dr. Gautam is a senior member of IEEE, a fellow of the IETE, and affiliate member of the Royal Society of Chemistry and a life member of VIBHA. He is also a member of IEEE Consumer Electronics Society's Technical Committee on Quantum Technologies. Dr. Gautam has published numerous research papers in esteemed journals, holds several patents, and has successfully managed various sponsored research projects that have been submitted, approved, or completed. His dedication to advancing quantum technologies and sustainable solutions positions him at the forefront of innovation in his field. Dr. Gautam's expertise in quantum technologies has led to collaborations with leading industry partners and academic institutions. His commitment to mentoring young researchers and students underscores his passion for knowledge sharing and development within the scientific community. Dr. Gautam will use the quantum gate model fundamentals and its application in route optimization, showcasing how quantum computing can transform traditional industries with enhanced speed and efficiency. Before we begin, a quick housekeeping note. Please ensure your microphones remain unmuted during the session to avoid disturbances. Feel free to post your questions in the chat box and we will address them during the question and answer session at the end. So without further ado, let us warmly welcome Dr. Kumar Gautam to share his insights and expertise. Over to you, Dr. Gautam.
Oh, thank you so much, sir. And namaste, sir. It's a great opportunity to interact with the on the emerging technology, particularly what exactly is the quantum gate model. And specifically, I am working on transport industry. And so here I'm more focused about how the gate model is supposed to be working for the transport industry. And also I will share the work problem where actually the people can connect with me and they can actually join as a research project and other options. Just I'm sharing this. So my presentation is visible?
Yes, sir.
Okay,
Yes,
thank
sir.
you so much. Okay. As sir told me that is basically the quantum frontier is very important to nowadays, and the government of India is also working on the quantum missions, and those who are working and those who really want to do in the quantum, particularly in the specifically the quantum missions. And there is four segments, but here I'm talking about the one segment verticals, what exactly the quantum computing. So how the quantum computing will help our to real-time use cases and industry like transportations, communications, health sector, and defense, and many more. But My goal is supposed to be like here the basics, how it's supposed to be like people can connect with this the quantum gate model, and how anybody can start like a gate model through the simulators. If I have a time, suppose also we'll share the about 2, 3, 5 minutes for how the circuit should be designed, and for the use cases particularly which simulator is more feasible to develop a quantum gate model. So, as I'm a founder of a QRace, QRace has started 2019, and this is my one of my startup. And in QRace, I'm focused on three goals. The first goal already I grabbed this opportunity, and the one of the project accepted. And right now, this project is from the Korean project, and me and my professor is actually working on the quantum control gate with the assisting of the quantum reinforcement learning based on ion trap. So this is specifically for transportations segment. Second goal is obviously right now nowadays in India are more prone to work on the establishing the quantum communication channel. So this is also my second goal, and I've submitted one proposal to under one of the scheme under the government of India, which is exactly the quantum Schrodinger equations, Schrodinger communication channel for same classical source, but we have to optimizing or optimizing through the some AI model also. And third goal is more focus on the defense, and I pitched to DRDO also. So this project is somehow is positive sign to somehow the anybody can also join as in this project. I will also share in the last slide how supposed to be like people can join in this segment. So this project is more concerned about the quantum radar based on the quantum dots technology. So let's start from the basic first. How the quantum computing, and this year, I mean, really congratulate to Pavan sir to initiate this FDP, and this year UN already announced the 100 year of the quantum. This FDP, this institution is also celebrating the 100 year of the quantum computing for particularly. So how the 100 year means what exactly? Which of this particular scientist to supposed to be connect with this 100 year of this? So if you connect with this story, no matter this slide, you are really connect with all the segment what exactly the people are doing in any of the applications in a communication or computing or health sector. So journey started from the 1925. This year is now the year is 2025. So almost people are talking this is emerging technology. As per my concern, obviously it is emerging technology, but it's already started in 1925. And the first, the two scientists actually, the Heisenberg and Schrodinger, started actually teaching about this concept about the quantum mechanics and all. So as I told that, simply, I mean, these two scientists actually, how they started. So as per the basic is, if you talk about the what is the kinetic energy, what is the total energy? Total energy is based on the kinetic plus potential. So based on these two concepts, the two scientists started and they capture this the two models like one is capturing this kinetic energy terminology and one capturing the potential terms, particularly the potential energy. So if you talk about the total energy is the kinetic plus potential, so kinetic is what exactly? P square by 2n, and potential you just love the potential, it's considered as a b. So these two scientists, Heisenberg and Schrodinger, started like in that way to it's interactions. So Heisenberg is more concerned about the potential terminology. So they said in my interaction picture, so the potential should be vary with the time, and in Heisenberg's interactions, the potential should be constant and momentum are vary. So Heisenberg is always like you heard that Heisenberg uncertainty principle, that is the momentum and position cannot change simultaneously. So based on these concepts, the Heisenberg with the momentum terminology and Schrodinger started this concept is the potential. So, but the question is, what is quantum? I mean, if you're supposed to be definitions, the people are many times people are confused. If you are engineers, it's really do we need the physics? Yeah, the physics is always needed, but what exactly the in terminology? Because quantum technology is something is related to engineering. So as per the simple definition of the concept behind this Schrodinger said this quantum is a mathematical framework. It's not exactly the physics, it's not exactly the mathematics, it's the framework. And this framework defined by uh, wave functions. So Schrodinger thesis was also the title was wave mechanics. So Schrodinger told like the quantum is a mathematical framework described by wave function, and that wave function describes a Schrodinger equation. So this is a simple definition, and that definition also written in Nelson and Chang book. If you go through the chapter 1 and the second page, it also mentioned that the quantum is what exactly it is. But the what exactly in 1925 when he proposed idea behind this concept of the quantum mechanics, the definition of the quantum mechanics, but the real interpretations came after next year. It means 1926. The Max Born is actually the person who actually interpreted the wave function concept, and then the Schrodinger and Born is somehow the Born is actually proving the Schrodinger equations of the statistical predictions of the variation variable rather than the exact predictions. And then many scientists came, PM Dirac, and then after the Feynman, Schwenger, many other Nobelists came. But in 1982 was that year was really it's a very big year when the Feynman first time they proposed the idea behind this. We had to create some machine based on the law of quantum mechanics instead of the law of classical physics. But he proposed somewhere in the one of the biggest company who is right now the stakeholder is the IBM. But at that time, IBM was not exactly at that time prepared about this developing the quantum computer. So somehow he is not accepting the idea. But after 1985, when David Dutch developed the quantum Turing machine and showing this, we can also develop a quantum circuit as a universal quantum. And 1904 and 97 these two actually professor and actually came and they actually pitching about the developing the quantum algorithm. So factorization one is Peter Shor is the pitching about this quantum algorithm for the factor very large number of polynomial time. And Grover is, as you know, that very famous algorithm is the Grover search algorithm. So he developed a complexity of this algorithm. So now this year 1997 then they started the talking about the quantum algorithm and basic things about how exactly. But still, they are not supposed to be connected how the quantum mechanics supposed to be working, how any like data will carry optimizing the data. But the year line 2022, that year was really again the who's working. I did my PhD in 2017, and that was completely it was a theoretical approach. But when 2022, this three scientists got the Nobel Prize, and based on the experimental of the entangled photons, establishing the violation of the Bell inequality and pioneered the quantum informations. And back to back 2023, again another scientist, these three scientists got the Nobel Prize based on the discovery and synthesis of quantum dots. So now the year is supposed to be back to back. The many, application and recognition is come across this concept. Now, then government is many countries, US, India, China, then started to, let's start to make a quantum computer. Already the IBM is started, many other companies also started, but now the India is also in prone to work on this forward, put forward in this under the mission 2031. We have to also develop a 1000 qubit based on the quantum computer or somehow is already TFIR is 6 qubits quantum chip is they developed along with the DRDO and TCS. So now coming from the how I motivated supposed to be. So as I said that this is the journey. If you connect with this story, you can also connect with this the story behind how anybody should supposed to be connected and start the quantum computing terminology, starting from the Schrodinger to till now today, 2025, the UN is already celebrating the quantum year. So as I said that the quantum mechanics is a mathematical framework and which is constructed by the physical theory. And that physical theory actually popularly known as the quantum electrodynamic, which is given by the Feynman is actually the person who actually, but actual person was the Dyson was real the person, but due to some Nobel committee, he did not get the Nobel and any prize for that because of some certain reason. But the idea actually they created the electrodynamic by the Dyson and along with the Feynman also. But he famous because he got the Sun Nobel and he developed many ideas, the Feynman path integral and all. So this is the actual concept. If you connect with this motivations or connect with the story behind this definition of the quantum mechanics, this is the complete definition of the quantum mechanics. So it provides the how it is related to the obviously in classically it's not actually explained on the atomic and subatomic level. So now we are supposed to be talking whatever that I'm talking about here now today we are actually connect with this visualize with the to connect with the atomic and subatomic level. It's not like so physical. So classical theory is not applicable for this atomic and subatomic. So now As I said, the already definition is the quantum mechanics or quantum computing is what exactly. Now, if you want to really connect with these three blocks, see, these three blocks is actual pictures behind this concept of the entire quantum mechanics. You want to develop a quantum algorithm, you just connect with these three blocks. So what is the postulate of the quantum mechanics? Total postulate total is almost four, but I am here just showing this a three postulate because as per my concern, as per you are also supposed to be as a researcher, you want to develop a quantum algorithm, you want to work at a quantum gate design using that. So just connect with these three. I will elaborate each block's later stage, later slide, how I started and how it's supposed to be connect with these three. So postulate is what exactly? It is the complete process of the quantum computer particularly. So first postulate is talking about, just you have to remember is this slide. Later, I will explain how every block is supposed to be connected. So first block's postulate is basically talking about the preparation of the state. State means now you are supposed to be connected with this is the state. And a state means energy state particularly. So in the first block, you have to prepare your states. When you have prepared the state in the form of energy, here energy is it is called a Hamiltonians. Okay, so first you have to prepare your state. When you prepare your state, then you have to put into the quantum system. Second postulate is actually the describing the quantum system. Now the quantum system evolve. Ideally, after evolutions, it will give the output is unitarity. This is the ideal conditions. Later stage, I will share what exactly is, if it is not unitary, what happens and why the quantum computer yet to be not yet to be in the picture because of this evolutions. So ideally, the quantum computer always it's acting as a unitarity. Means what exactly is whatever the input you are giving, a unitarity means if you just consider 2 cross 2 matrix, all the diagonal elements should be 1 and upper and lower triangle matrix should be 0. This is called unitarity. So output is supposed to be unitary. If it is unitary, you have to measure the information. The third postulate is talking about the collapse. Basically, you are measuring the information based on the probability and all. And that also I will show you. I will show you what exactly the measurement is process. And the last postulate is talking about the composite system when the multiple system are connected at the same time and talking related to each other. But now in this talk, and you are also, if you want to start developing a quantum gate, basic gate, just connect with these three blocks. And if you are clear about this postulate, you can start your quantum research or you can start your building the quantum computer or quantum algorithm and everything. So first you have to prepare the state. Second, after preparation, you put the into the quantum system. When it will evolve, the output should be always unitarity. And third, you have to measure the information. So third postulate is the measurement. Now coming to the why it is so significant. Like as you classically, you know that this is the basically the 0 and 1 means every information either is in the form of 0 and in the form of 1. It's like a transistor. But in quantum, it is at the same time, it's both the state should be right. Like this, like you can see this diagram. The Z is upper axis is cat 0, that is the north pole, and lower is basically this is a Bloch sphere. Sorry, this is a Bloch sphere. So North pole is 0, South pole is 0. Some point there is this is basically superposition points where you are the 0 and 1 at the it will show that at the same time. So I will show. So it built the quantum computing or qubits particularly, which is represent the combination of 0 and 1 at the same time through the superposition. And superposition it is not like the new terminology when we studied during the 10 plus 2. We know that during the differential equation when you will solving the we know the superposition. During engineering, we also study the superposition. Superposition means what exactly? There is a two, the condition should be validated. One is the homogeneity, another is the linearity. I will show you also that what exactly the linearity and homogeneity are based on the wave equation. So qubits are interact each other through the entanglement concept and allowing them the scale of the exponentially and process of the information parallelly. So that is the correlation. So each qubits are correlated each other. So based on this definition, I'm just please just connect with this see this diagram. So see that the superposition means at the same time all this is all 3 points are connected. So all the qubits are connected each other. Now next is entanglement. Entanglement is see that the third diagram is basically this all these are coherents. Means the system are entangled, the whole and more than the sum of the all the part are defined as the particles of the matter. And the second diagram is basically it's related to the correlation. So each qubits are correlated each other. So based on these diagrams, this is the basic the three definition of the quantum mechanics and validated for particularly one is superposition and second is correlations and third is entanglement. Now coming to this simple definitions, so like that. Classically, it's like a zero and what how should be like a, information is represented? Represented it's in the form of binary basic language and it's acting as a transistor. But in a qubits, it's basically electrons are basically it's dancing the spin concept, which is exactly the magnetic orientation. So state is basically represented the electrons basically in this form. So this plus one is half spin and minus one is the minus. That in the second postulate, the
This
after
meeting is
evolution,
being
the output
recorded.
is what exactly it will give the unitarity. Unitarity, the maximum probability should be always it should be one after measurement. So based on these equations, now the quantum mechanics is based on this equation. The quantum mechanics is what exactly is this is actually the maximum the probability is one. So quantum mechanics is the probabilistic mechanism also. So quantum mechanics is a mathematical framework. Quantum mechanics is a probabilistic mechanism also based on this. Okay. Now coming to this uh, definition of if you are representing the cat 0 and cat 1 in terms of matrix mechanism, suppose, so matrix mechanism is how it's the cat 0 is if we can define the column vector. So 0, 1 and 0, and if cat 1 is equal to basically in the column vector 0 and 1. So if you're representing this, each state in the matrix form, it is called matrix mechanism, which is actually given by Heisenberg. And the notation was given by Dirac notation. So these three scientists actually, Schrodinger explained about this, the concept behind this, the quantum mechanics means based on the wave mechanics and which is actually given by Schrodinger equation. Second, based on this equation, a square norm square plus b square is equal to 1 is equal to 1 means quantum mechanics is a probabilistic mechanism because the total probability always it should be 1. And third, if you represented each state in the form of the matrix mechanism or matrix form, so which is exactly the quantum mechanics is a matrix mechanism also. So the condition is basically all the quantum operation have to be reversible. This is also a very important condition. Have to also, if you can
This
develop
meeting is being
if your
recorded.
output is unitary, so how will check it is a unitary? So you have to just you dagger multiply with this, and if it is the matrix is equal to this one identity means your job is done critically. So up to now, I'm just giving a basic idea. Now, how we can start this idea to how we can to define or to develop a quantum gate, we'll see that. So this is as I there's the two qubits, cat 0 and cat 1, and we can represent the wave function is a superposition state alpha cat 0 plus beta cat 1, and the norms of alpha square plus beta is equal to 1. And as I said that the cat 0 and cat 1 you can represent also in the bra form. So if you represent your bra form, then it is a row vector. But we are talking about this always in the column vectors. So cat 0 and cat 1 are the orthogonal computation basis function, and this is the way is how we can you can
This
start to
meeting is
design
being
or develop a
recorded.
quantum gate. Here I'm just here I'm showing you the ion trap. Don't consider the ion trap. If you want to start develop a quantum gate design, first you have to identify which quantum system you want to work. Like you are when you will go to market and you want to purchase any book, like any laptop. So the people think about it. We can either HP will take either Apple or Dell, anything. So based on the characterization and based on the stability, you are also defining the purchasing the computers or classic computer. So same you are also you have to identify the which quantum computer is supposed to be you want to design or which quantum computer you want to actually develop. So starting from there, you have to take from the harmonic oscillator based simple. I will also show how you should maybe develop a quantum gate based on harmonic oscillator. When you have identified the system, then you have to start your developing the quantum system. And now the next is interaction. Interaction means how your gate supposed to be, whether it will be the atom or molecules interaction, whether it will be with the electric field or magnetic field or electromagnetic field. That is also. So if you want to start a basic concept for the designing a quantum gate, let's start from the electric field only. Don't consider the electromagnetic field. Don't consider as a yeah, magnetic field. So if I want to develop a quantum gate, simple harmonic oscillator with interaction of the electric field. Why is supposed to be I'm saying? Because the total energy is the kinetic energy plus potential energy. Just consider the kinetic energy is just constant. Don't consider in the Schrodinger interaction, kinetic energy is a constant with not varying with the time. So what exactly the varying? Varying is your potentials. So the first potential is just unperturbed. The second potential is basically you are carrying your actual information. You are carrying your the interaction picture also. So the potential is what exactly? You have to just write a Hamiltonian and the based on this unperturbed Hamiltonian, there is no any disturbance and a small disturbance you are putting and this is exactly the perturbed Hamiltonian. So total Hamiltonian. So you want to develop a write a quantum gate design. So first you have to develop first you have to write a equation of the Hamiltonian. So when you have prepared your Hamiltonian, then you can start using the Schrodinger equation first order and then using the unitary evolution technique and identify this quantum gate. So these are the basic things like coming to the Schrodinger, how it is like supposed to be Schrodinger equation. So this is the first order Schrodinger equations. I h dagger dip psi by dt is equal to h psi t. So what h dagger is equal to reducible Planck constant. So you have to just consider is one, and you just this I goes to the right hand side. So what is the equation? Psi dash is equal to minus I h psi t. You have to just connect with this equation your dynamic equation because quantum system is a dynamic system and as you know in if you are engineer you have studied the control system. So and during the control system you study the dynamic system and dynamic system the definition is also the one equation is validate for the state space equation and second is the output equations. So what is the state space equation? This is simple x dash t is equal to axt plus but, but but is just 0. So what exactly is x dash t is equal to axt and compare with this equation. So x dash t is equal to AT is the simple differential equation. If you want to solve the simple differential equation, what is the xt solutions? The solution of the xt is equal to e to the power AT into x naught. So just compare with this state space equation with this Schrodinger equations. So what is the solution of this Schrodinger equation? Same like that, you have to put just a is equal to minus h. So psi t is equal to what exactly is equal to minus e to the power minus I h t psi naught. So you can see that e to the power minus I h t means it is a complex exponential signal. You can just see that I am just saying just a minute. Okay. So sorry. Just what exactly is just I'm if you understand about this equation, I said simply first you have to write a total equation. Total energy is equal to kinetic energy plus potential energy, and kinetic energy is p square by 2m plus potential. Just consider v. So based on these two equations, two scientists came. As I said that. So so this is actually the momentum and this is the potential, right? So you have to write the total h naught is equal to p square mass is equal to 1 plus v. And what exactly? You have to take a harmonic oscillator. So harmonic oscillator potential is equal to half m omega square x square. So take a mass 1, omega is also 1. So what is the equation is h naught is equal to p square by 2 plus x square by 2. Okay. So this is simple a square plus b square. So we can write like that x plus iota p by root 2 into x minus iota p by root 2. We can write like that. So this is called A and this is called A dagger. So this is called creation preparation in terms of Hamiltonian. When you
This
have prepared
meeting
your
is being
Hamiltonian,
recorded.
you have to put into the quantum system. And then you have to measure whether this output is unitary or not. This is the actual goal. If it is unitary, then your job is done. Your quantum computer is developed. If it is not unitary, then it is you are facing some problem. So you have to work on this side particularly. So I just said that the quantum system is a dynamic system. So dynamic system is a simple x dash is equal to axt. And if you are solving these equations, xt, the solution of this equation is e to the power at x naught. Simple. Now I said that you have to compare this equation into Schrodinger equations. And Schrodinger equation is what exactly? I h dagger dip psi by dt is equal to h psi t. Got it? And where h is equal to just 1, it is a reducible constant. I को हम लोग just you have to put in this side. So psi dash is equal to minus I h psi t. Now you have to compare with this equation to this equation. So what exactly is? Simple. Here is the x dash, here is the psi dash. And here is xt, this is psi t. So what is the simple? Just you have to, what is the solution of this equation and this equation? Nothing. So you have to replace a is equal to minus ih. So this, what is the solution of Schrodinger equation is psi t is equal to e to the power minus I ht t psi naught. So this is actual your solutions of wave equations. Now when you prepare your psi t, now you have to put into this quantum system. When you are putting into the quantum system, then you have to check whether it will be unitary or not. Now you have to solve this. So as I said that the quantum system is acting as a unitary evolution. So you have to replace psi in terms of u. So you have to check this. Psi, I am just replacing this equation psi in terms of u. And the total, this is nothing but this is h naught plus next Hamiltonian, this is h1. So because the quantum system obeying the unitary condition, so we are actually using the unitary technique here. And then you have to solve this unitary equations. Now check whether this ut should be unitary or not. So till now, the mathematical part is basically done. Now I'm showing this based on the block diagram, how anybody can start like that. Just connect with this block diagram. So this is what exactly, if you want to develop a quantum system here, suppose, so first you have to write a h naught, and h naught is I told that what exactly is p a square by 2m plus v, and the v is because we are considering the Hamiltonian, sorry, harmonic oscillator, so you have to just replace the v in terms of what is the potential of the harmonic. If you are considering superconductive qubits, you have to write a potential in terms of the superconductive. If you are consider a ion trap, you have to change the just v. You have to consider the NV atom, you have to change just v. So what exactly is, how you have to prepare this Hamiltonian? You have to replace this v. And in the Schrodinger interaction, this momentum term is always constant. The next Hamiltonian is this, is epsilon, because next Hamiltonian, if we are not considering the potential momentum, so next Hamiltonian is just h1. So the total Hamiltonian is what exactly is h0 plus h1. So this is h1. When you prepare your h, now you have to put into the quantum system. And quantum system obey the Schrodinger equation. The Schrodinger equation the same, psi dash t is equal to minus I h psi t. Now your h is ready. When your h is ready, you have to put into the quantum system. The quantum system start your the operations, and you have to check here whether this ut is identity or not. If it is identity, then your job is not supposed to be next, is it's complete. Your job is done. But the problem is in the real time, this operation is not identity, because the one is, it is infinite. The quantum system is actually, it is about to infinite dimensions. Okay. So how you're supposed to be, if you're one write a equation, any equation, suppose if you solve this Dyson series based on equation, so psi dash t is equal to I minus epsilon 0 to minus infinity to plus infinity and something into dt. So yeah, if you want to just taking this for the unitarity, so you have to first truncate this. So this epsilon to truncated. Truncated means just you have to discretize. When you are discretized, now this ut is term of u of t. So I use this discretized technique here. I use this discretized technique, Dyson series, TDS technique. So put in one switch. If it is not unitary, then you have to start the next process. So what exactly? In my case, 2015, where I was published one paper based on that, and the first we defined a Hadamard gate, develop a 2 qubits and 3 qubits Hadamard gate, and check whether it will be unitary or not. But what exactly is when they are interacting each other? it hardware gate lost the unitarity. Then I change the control gate. And here I am also develop the protocols of the control gate. So you can also use these protocols, and this is you are the random variables, random matrix 2 cross 2. So simply if it is random, then what exactly, if any H and V take a random R and D, if you are working in the 2, this is also a rand 2. So but these two are Hermitian. That is also one of the conditions. How it is the Hermitian? So H naught plus H dash by 2, then automatically it will be Hermitian. Hermitian means A, B, B, C. If it is like that, this type of matrix, then it is. So when you start the simulation or any programming, first you have to validate this H naught and V should be Hermitian also. Okay, so I developed this control gate, and you can use use these protocols, this implementation for the control gate also. So this is the basic diagram. Now you have to check whether this is the comparator. Now this is your derived unitary gate and this is your given unitary gate. This is always, the given unitary gate is always identity. Derived unitary gate is not identity. That's why we are started this process. Okay. So how it will be unitary? So I use this cost functions here, and this is called Frobenius norms cost functions. So what exactly? So we have to find this gate error energy. If it is the discrepancy between the given gate and this derived gate, it should be minimum. Means if it is UG is approximate UT, then your job is done. Means if it is about to zero means your derived unitary gate is comparable to the given unitary gate. So this is the actual concept. And if you want to develop a quantum algorithm, anyway, you have to also start the same process. So here I am showing one example how I develop a quantum control gate. How you can start like a QGSO or any quantum optimizer. So like seems you can just connect with this block diagram. Please see this. I have bifurcated the four segments. 1, 2, 3, and the last. So again, see that first I have prepared the H naught, the same. So you have to also start the H naught. H naught you have to take a Hermitian 2 cross 2 matrix, simple. Then next is Perturb Hamiltonian. So this again this potential. So your data is who will actually carry your data. This is actually your modulator. So this is your agent who carry the information. So I just modulated with this potentials. So what is the output of this? Output of this simply the next Hamiltonian means perturb Hamiltonian output is epsilon modulate Sk and V. But one condition have to remember that this Sk and V are not commute each other. Because if it is commute each other, then obviously you lost when the process will start, then you lost the information also. So this V and Sk are not commute each other. Now you have to define the Hamiltonian. So I define this Hamiltonian and write the wave equations of the Schrodinger equations and put into the quantum system and check whether this derived unitary is your derived unitary gate is identity or not. But it is not identity, so I use the truncated Dyson series. This is writing. This is the same equations I'm here, and then I have to compare with the comparator using the Frobenius norms, the gate, and then defining the gate error energy. So till now, as I said, this process is same. Where it changed? When I define this gate energy and check it should be minimum, then I use this gate error energy as a objective functions. Okay. And I am putting here the quantum GSO. I mean, GSO particularly, I put the quantum means term of why I'm putting the quantum means because the entire process through the quantum, the data is carrying through the quantum and reach to this one. And now I put this GSO, and this GSO is actually the start the process through this how you can start like that. So first, the first segment, you have to again prepare the H naught. This B is your potential, put in the your data and write a H naught. So anybody is supposed to be on to develop a quantum algorithm, first have to write the Hamiltonian. When you prepare your Hamiltonian, then you can start the second step. Second step is what exactly you have to check whether this unitary derived unitary gate is your identity or not. If it is not identity, then put into the discretization technique and compare with the compare with your ideal one to derived one, and define this, the gate error energy should be minimum. When it is minimum, then apply the GSO, and this GSO is working with the mass based. So how it will work, when the larger the mass, optimal value. So this is the actual process, and I'm writing some mathematical equation based on this. See this, you can see the step wise. I here also I'm writing step wise. The first step, you have to just 2 cross 2 Hermitian matrix, put the epsilon is also 1. Now H is ready. Then you have to write the Schrodinger equation, use the unitary matrix, and evaluate. You have to just expand this exponential term using the unitary evolutions. When you write the UT, then put into this get error energy and check whether zeta mean should be identity or not. When it is identity, then you have to estimating your information based on your the mass, and then the mass should be like estimated, and check whether these conditions, these two, if the larger the mass, the optimal the value, and minimum value, and this is a reversible, like reverse process. So like larger the minimum and minimum the larger. So based on this, we have to reach this particular uh, just a minute, this one. So what exactly is, if this is the one vehicle is, this is your depot, um, this is your depot, and you have to check also if each vehicle, like there is a 4 vehicle is there, suppose 1 2 3 4 vehicle is there, and based on the city, how you have to start this to your city, your vehicle is supposed to be reaching the to your city, and optimizing the routes also. So this is the actual structure, and you can also check further. You can also use this optimizer for your security checking also, whether it will the any malicious activities occurs or not. So this is the systematic diagram. You can also start for the transport side to develop a quantum optimizer particularly, and you can choose either materialistic approach or simple hybrid approach. So in this domain, there is one company, D-Wave. He already using the technique is QAO, and which is exactly hybrid technique. Particularly, it's not exactly the quantum algorithm. So if you want to work in the quantum algorithm, please start the process in that way. What exactly I'm defining here, and then you can develop any of the optimizer, and writing the mathematical equation and developing this. Now coming to this, which simulator is supposed to be, you can use this. So I'm suggesting, I mean, people already know about this Qiskit and many other simulators also. You can also use the Qiskit and other simulators, but I'm just suggesting to you for the very easy, you can start this simulator. Particularly this is okay. This is the QPS. This wavelength is a quantum dash circuit.com. So please, you can also, it's a simple, you just write and register and log in. After logging, your wizard is open like that. Okay, so how it will start, just drag and drop. So if you want to like a simple this Hadamard gate, then one more Hadamard gate you can add like that. So like this, just showing how actually it work, and what is actually how you can use this simulator for defining this. So this two, and now I am putting here one control gate. Just check this, and then apply one measurement. You can apply both the measurement. You can check whether it will be the output is there. So when you are defining, so Hadamard, why you are always using the Hadamard gate particularly? So simply for initialization purpose, you can also use the Hadamard gate particularly. So it will give same like that. So Hadamard gate, I'm just showing this what exactly the Hadamard gate operations and what is the equation, how we can write that. So like if you can draw this simple, there is a 2 qubits. So what, how many combination is the 4 combination? If I simulate this one, see this. After simulation, what is the output? Output is coming to the each of the states. So 0 0 0 1 1 0 1 1. And I said that total probability is always maximum is 1. So 25%, 25%, 25%, 25%. So it is always, it should be 1. So as I said, the norms a square plus b square, always it will be give a the 1 is also. So coming to this one, so I am just adding one more Hadamard gate here, and one more Hadamard gate here, and we have to just simulate it. When you are simulating, what exactly is actually, this is actually the Belpaire violations circuit diagram. You can see that all other states is 0 0. See 0, 0, 0, and you can see the state vector is the maximum output is coming to the only one first channel. This one. If you're removing this one, see that what is actually the changes. So this is the actually the state vector is the 0, 0 and 1. Means output is coming to the two particular. The 50% is coming from the one state vector, 50% is coming from the second. So if you compare with this previous one and this one, this is actually the Bell pair, the circuit equations when your output is coming to the 50% here to 50% here particularly. And why I'm showing this diagram, you can just click this. When you're clicking this, what exactly is this? If you compare with my first block, see the first is 0 cat 0 cat 0. So I said that when the quantum postulate, particularly the first postulate, what exactly is prepare your state. So this is actually the your state, scat 0. When you prepare your state, then till now this till this one. So this is your quantum operation. So when you are putting this, the output is coming to the operation is started, and these two are basically the measurement. You are measuring the information. When you are measuring, if it will be the unitary, then your job is done, and now you can start. If it is not unitary, you can write your cost function. So in my case, the cost function is Frobenius norm. You can see this here. If you compare with this block diagram to this one, please come to this picture. But exactly, first you have to prepare your state. State means your agent is started like a Dakia. Your agent is ready to take care of your data. If your state is prepared, now you put into the quantum system. Here also I'm saying that now my state is prepared. Now we have put into the quantum system. And that then you have to check based on this measurement whether it will be the unitary or not. If it is not unitary, now your cost function. So in my case, here the cost function is what exactly is? This is actually cost function. I'm using the Frobenius norm. You can use other norms also and check whether it will be validated or not particularly. So I define the cost functions. You can write your cost function here in that way. Just click it. This is simple Python programs based on that. You can write it Python program here and okay. Now your cost function is ready. Now you have to next job is when your cost function is ready means your gate error energy is minimum. Then you have to optimize. Inbuilt already there is three optimizer like a Powell, Cowell, and ATAL. But I suggest to you you can use another optimizer particularly. Don't use this or starting for the learning you can use this Powell or Cowell also, but Cowell's also. But I suggest you to write on your code and to simulate it. So how you can supposed to be writer? You have to export it. Here you automatically as per your circuitry. Now here is your Python code is there. So you can write your you can change your circuitry as per your demand, and you can write up cost functions also as per what exactly you want to work on it. But if you want to develop any other cost function, you can start like that. So this is the basic simulators, and you can also use. My job is to have to understand about the how every like this process is have to check what is the output of this Hadamard gate. So if you want to just give me just 2 minutes, if I will drawing here simple diagram. This is cat 0. This is another cat 0. I'm just putting cat H. Okay. Forget about this another. So cat 0, the output is, the input is cat 0. And see this, where you are putting the Hadamard gate, this is the first channel and this is your second channel. Okay. So the Hadamard gate when H cat 0 is basically 1 by root 2, 1 by root 2 cat 0 plus cat 1. When Hadamard gate is effect on cat 1, then this is the equation 1 by root 2 cat 0 plus cat 1. So I said you have to check also what is the output of this Hadamard gate. So how? So where you are putting this Hadamard gate? In channel 1. Channel 1 means here you are putting. So just H cat 0 tensoring with cat 0. So this is actually the tensor product. So what is the actual equation of cat 0? This is the cat 0. So 1 by root 2 cat 0 plus cat 1 tensor with cat 0. So what is the tensor? The tensor with this 0, 1 is tensor with. So what is the output of this? So total output is 1 by root 2 cat 0 0 plus 1 0. So if you want to check, the first output is when you are applying Hadamard gate here. So first output is 1 by root 2 cat 0, and another is 1 by root 2 1 0. And then we are putting control gate. So what is exactly the control gate? What exactly you are putting in the first channel? So first channel control gate, what exactly is said? And effect is the first channel. If it is a 0, the output is same. So if it is a 0, the output is same. So means output is cat 0. See that. If it is a 0, if it is 0, the control gate is what exactly? Don't change. So the control gate is output is 0 0. But if it is 1, the next adjacent the bit it's flipping. So the output is what exactly is 1 1. So what is the output of here is it is a 1 0 0, and in this channel is 1 1. Okay. So if you want to check this equation, you just replace this this h1. You have to replace this also, and you have to disable. Okay, and just auto run on. Check this output. See this, whether we are right or not. See this. My output is also what is the my output is 0 0 1 1. Okay, and this the magnitude is 1 by root 2 1 by root 2. You have to check in the simulator also. See this 0 0 0.7, the 50% 1 1. Okay, so don't always like a like spoon feeding. You have to check each state and then verify through the simulator also. So this is I'm just explaining about how you can start mathematically through that calculations and verify your quantum gate circuit through your simulators. Not only you don't use always like a simulator particularly, you have to check each steps, and then so steps I already defined this, and based on that you can run. So you can build any of the then apply this one more Hadamard gate, one here Hadamard gate, and then you have to also calculate as per this simply. So till now, I'm just uh, this is clear, and this you can build this quantum optimizer as I said that. So what exactly the QRace is doing it differently, particularly? So I am working in this. One segment is also more prone to work on the quantum computer, particularly the ion trap. So my major work during my PhD, I was also working on the ion trap and published one paper based on this ion trap using the matching generators. So you can join this. This paper, this is my optimizer. You can download this, and last year it was published, the quantum path integral approach for vehicle routing problems for the limited qubits particularly. So it published on the IEEE transaction. So I during South Korea, I developed two optimizer, one for the Hyundai motor and one for my startup. This is for Cubai. So next is why it's supposed to be. We have to also, and when you're doing the research, try to connect what is the market and opportunity regarding that. There is a huge market that people demanding right now. The company wants to, the developer company wants to mathematical algorithm developer. Maybe a company wants to basic analytical analyst to about understanding of the quantum computing. So after 5 years, definitely it completely changed, and India is also somehow in some industry it will lead also in automations, communications, etc. and all. So these are the software, particularly simulators. But don't confuse about that. Use Qiskit and QSM and QPS. And for particularly those people who are working on machine learning, particularly, I am suggesting to Panyland. So I will share the this link also to Pavan sir. You can also start this Panyland. Is a more and for the developing this machine learning particularly. So these are the actually the sectors where I'm right now working on this. And here I'm just sharing this concept. I'm sharing this slide to everyone also to try to connect what exactly right now I'm looking at people who want to work on the quantum radar development for the quantum dots. So again, I'm working on some new quantum system. What exactly is the dots technology? But my dots technology is something is different. What exactly the people are working. So I'm using the waveguide and putting the inside. I'm putting the ions inside the waveguide, and we build the one another atom like the Rydberg atom. It is the same the family of the hydrogen atom, and how you have to write develop a quantum system. So then same. First, you have to prepare the H. As I said, that you have to prepare the Hamiltonian, and when you have prepared the Hamiltonian, then apply this. The putting the quantum system is particularly what exactly in my case is Rydberg atom dots technology, and we have to develop the large size of the quantum unitary gate. So till now, this my talk is somehow is related to this, and I'm sharing my opportunity. It's what exactly the people want. See, this is the actually, I mean, every area you can apply this concept is quantum computing. So what exactly you have to start the basic writing the Hamiltonian basic concept. Choose a harmonic oscillator. Don't compare with the any. If you have already knowledge, then choose a ion trap or superconductive qubits or photonic anyone. But those who don't have any idea about that, choose starting the basic book. Basic concept is the harmonic oscillator and apply this. So next internship program already is going on my in my company and the institutions. Next internship is also very soon will be announced somehow, and to particularly in the some project also. Thank you so much. If you have any questions, please.
Participants, if you have any question, then ask.
If you have any query and any related to information, please ping me. My I will share my email ID and other things.
Hello,
So
sir.
yeah,
This
yeah.
is Amrita.
Yes, hello, ma'am.
Yeah, yeah, sir. So I want to ask just if I want to do a research in the healthcare, so can
Yes.
I use this whatever we have discussed now, the algorithms that I can that can I use in the healthcare also?
Yes, sure. You can use the QNN technique for developing the quantum gate model, particularly. Gate
Okay.
model is a basic concept. I mean, if you develop a gate model, you're applying in everywhere, whether it will be security, whether it will be the concept of this uh, health sector also. So if you want to use QNN particularly, so QNN, what exactly you are developing? You are optimizing the weight functions, right? So optimizing
Okay.
the weight functions, apply the weight function with multiply with your like uh, Edward gate and put into one single qubits. So H multiply with W and with multiply with cat zero simply. So starting, if you want to start a health sector particularly, the basic concept is you can start simple QNN particularly for developing a hardware gate first, and then apply your health sector, either it will be the brain interfacing or it will be the EEG or anywhere. But this gate model is very fake. I mean, if you are supposed to be want to learn in any use cases, but whether it will be health sector, transport, or communication, to develop it to concept is this gate model is very important to everyone. And you can also use that like the same. I said that you have to prepare the Hamiltonian. Means if you want to learn a quantum system, so quantum system can understand only Hamiltonian. So you have to prepare your Hamiltonian. Once you prepare your Hamiltonian, you can start your any of these use cases.
Yes, sir. Thank you, sir.
I mean,
Any other question? Participants, you can unmute themselves now. If you have any question, then ask them.
So your session is very nice. Just want to refer the papers you have mentioned. So if we can get the papers to read, it will be a really great. And thank you for the session because it is really nice. We got more information with respect to our research. Thank you, sir.
and There is another startup I know. This name is eGreen Quanta. Just go to the website egreenquanta.com. I spreaded 25 problems in every verticals. I bifurcated the quantum computing, quantum communication, sensing, and that materials. So if you want to work with me, just go through that, visit my website, egreenquanta.com, connect with, and just ping me, sir, I want to work with this, like any like that. Either you are supposed to be interested in the health sector. Already in right now, I'm hiring 45 intern. So eight intern, eight sorry, 40 interns, eight group divided the eight project. One of the project is basically working on the student are developing a quantum neural network for brain interfacing. The same gate model particularly. So you
Can
can
you
join
name
also.
it
I mean,
again,
by
sir?
what? Pardon?
And can you name
E
it again, the company name?
eGreen Quanta. eGreen Quanta.
E-Green Quantum. Okay, okay.
Yeah.
Thank you, sir.
Yeah, I will share this also. egreenquanta.com. So on this website, my second startup is, and that startup is right now. So working on the many verticals. The one of the verticals is particularly the quantum computing, where you can try to connect with this. So I have also, I mean, some project opportunity to those who want to pursue as a research particularly. So kindly just join me with, and they can work with me also.
Sure, sir. Thank you.
Yeah.
Would like to
Thank you. Yeah.
join. Yeah.
So one participant asked the question in chat box, how this model helps to solve security issue.
Yeah, it is also. I mean, like one of the problems is like a PQC or a quantum. This model is quantum gate model is everywhere. Like what exactly? If you have a security data, so you have to optimize or tackling this malicious. So you have to develop a quantum algorithm like a cognitive based optimizer. There is one like that, and then in 2019 NASA used this the technique. So this is called the neurofuzzy cognitive based optimizer. So when you want to develop a tackling the malicious activities between these two nodes, as I said that where you are supposed to be, like between the two nodes, like a two transmitter and receiver, and some malicious activities occurs. So how you are supposed to be tackling the same model, this concept, you can apply this. The Hamiltonian, as I said that. The information whether I was putting this DRP data, you can put your security data inside this, and that Hamiltonian this will carry your data into the quantum system, and they quantum after the evolutions it will optimizing. So you can also develop a protocols, you can also develop a quantum algorithm for security data. So the two group is basically working on the one group is working on the how the secure channel is establishing by using the quantum random number generator. And second is basically the through the PQC, how we can suppose tackling this side channel attacks or quantum attacks. So as you can go through the NIST protocols PDF, I mean the white paper, they already mentioned that everything is there on this, but my suggestion is to don't consider it like people are working on the lattice based or has or dash based. You can first identify or read this really the quantum attack. Nowadays there is no such type of attack, but obviously in future when the quantum computer will come, and many country, I mean one of the country, I mean China is already working on, sometime we are threatening also, like they develop some attackers and some quantum attacks. So obviously you can use this gate model, apply on this the PQC segment, and choose any of this protocols and develop not new. You have to just modify the protocols, either it will be lattice or has and does. So this model is universal for applying for every cases use cases particularly.
Thank you so much, sir. Dr. Kumar Gautam, sir, for such an insightful and thought-provoking session. Your expertise on the quantum gate model for the transportation industry and its real-world applications has truly enriched our understanding of how quantum computing can bring transformative changes to this sector. We are grateful for the time and effort you have invested in sharing your knowledge with us today. The practical insights and innovative ideas you have presented will undoubtedly inspire further exploration and research among all of us. A big thank you to all the participants for your enthusiastic involvement and for staying engaged throughout the session. Your questions and interactions added great value to the discussion. Before we conclude, a gentle reminder to everyone, please wait for some time, another for up to 7:30 है ना phone another guest. Thank you so much, Dr. Gautam
Okay,
sir.
sir. Thank you.
Thank
Thank
you
you
so
so
much,
much,
sir.
sir. Yes. Bye. Bye. Take care. Good night.
Thank you, sir.
This meeting is being recorded.
Good evening, everyone. We hope you are enjoying the enriching sessions of this faculty development program on quantum machine learning, bridging the gap between quantum computing and AI. It's been an exciting journey so far, diving into the depths of quantum computing and its applications in various domains. Welcome to session 6 of day 3, where we will take a hands on approach to explore quantum computing through the topic practical training on quantum simulator QSKIT. This session promises to be an engaging and practical experience as we learn how to implement quantum algorithms using QSKIT, a leading open source quantum computing framework. Our esteemed speaker for this session is Dr. Jay Kumar, the founder and CEO of Anutantra Private Limited, also serving as IBM Quantum Educator and IBM QuizKit Advocate Mentor. He is actively building a quantum community in India. He is also an IBM certified associate developer, quantum computation using QuizKit. He has 15 years of experience in R&D and lecturing at the university level. He is an active senior member of IEEE and participates in IEEE quantum standards. To date, he has published over 15 research papers in international peer-reviewed journals and international conference proceedings. Due to his research work, he has been appointed as a technical paper reviewer for IEEE quantum conferences. He also conducted over 50 quantum programs, including faculty development programs, QSKIT certifications, training, and awareness camps across India, USA, Russia, and Armenia. In this session, Dr. Vaiswith Shankar Vaisweta Shankar will guide us through the fundamentals of QSKIT, demonstrate practical implementations, and provide insights into how quantum simulators can bridge the gap between theoretical concepts and real-world applications. Before we proceed, a quick reminder, please keep your microphones muted during the session to ensure a smooth experience for everyone. If you have any questions, feel free to drop them in the chat box and we will address them during the question and answer session at the end. Without further delay, let's give a warm virtual welcome to Dr. Jay Kumar as he takes us through this hands-on training on QSKIT. Over to you, Dr. Jay Kumar.
Thank you so much, sir. Am I audible?
Yes, sir.
Thank you. Thank you so much. Good evening to all. It's my pleasure to be here. And I thank Dr. Pawan Kumar Goyal for inviting me for this wonderful ATAL workshop.
Thank you so much, sir.
Shall I start, sir?
Yes, sir. Yes. Please start.
Yes, yes. Yes, sir. Is my screen visible?
Yes, sir.
Okay, great. Great. So once again, I invite you for this wonderful ATAL workshop. Myself, Dr. Jaykumar Vaidishankar. I am serving as IBM Quantum Educator as well as IBM Quizzkit Advocate Mentor. So for that, I completed IBM certificate, especially in quantum. So in this lecture, we're going to cover about the basics about the quantum computing. So before that, I want to highlight how I entered into this field. I am totally having 15 years of experience, 10 years from academia and 5 years from industry. So before 5 years, I started to study about quantum because of one Google video. So before 5 years, Google demonstrated quantum supremacy. If you go and watch, you will get a fair enough idea about how Google quantum computer works. So in that video, what they claimed, they took very hardest computer science problem, NP hard kind of problem, and they put in very world powerful supercomputer, and that computer will take 10,000 years to solve that problem. Okay, that much very hard problem. And they took the same problem in quantum computer, they got a result within 300 seconds. So you can imagine a problem take 10,000 years, 10,000 years in world powerful supercomputer, in world's powerful supercomputer. They put the same problem in quantum computer, they got result within 300 seconds. So this is less than 4 minutes. Okay. So this is very hard NP problem, very hard NP problem. Okay. By looking at this example, you're able to understand how powerful quantum computers are. This is what I want to highlight. Let's clear my. So if you want to study something, we need to teach others. Okay, if you want to study by yourself, it is very easy for you. But if you want to make others to understand, it is quite difficult. So what I suggest, the faculty who are attending this program, appear for this IBM Quantum Educator. So this is a program where you can enroll yourself. For this, you need to have a syllabus and you need to upload everything in your institute website, and they will call for interview. Okay, if you able to clear that interview, IBM will offer this IBM Quantum Educator honorary post. So I got this post before 5 years because I want to learn quantum. For that, I started to teach for undergraduate engineering students. Okay, great. So this is the first step I took. So after that, I enrolled in number of challenges. So each and every year, IBM offering open source challenges. These challenges are free. Anybody above 18 years, they can able to enroll. Why this is not coming right? Okay, above 18 years, they able to enroll. So if you are enrolling these challenges, you able to know what is the fundamental of quantum computing. Okay, so these challenges will give clear idea about what is the quantum computing. And if you're able to clear all this stuff, then you can focus summer school. So IBM offering summer school each and every year, which is free of cost. This course will take for 2 weeks. So you need to study for 2 weeks. So once you study, you're able to do the basic and fundamental about quantum computing. So this is advanced level when compared to challenges. So I request each and every one of you, you promote among your student community to enroll this summer school. Okay. So once you completed challenges on summer school, you can look for certification. So this certification is little tough, and you need to prepare 3 to 4 months for this certification. Okay, so IBM is there, Google is there, Microsoft is there, but only IBM offering industry level professional certification in quantum. So no other MNC offering certification. Okay, so no other companies offering certification. So once you completed certification, you can go for IBM Quizzkit Advocate. So totally from India, there are around 120 advocates are there. among 120 advocates, nearly 110 people from student community. Okay, so 5 from academia, 5 from industry. So once you got IBM Qiskit advocate, you can promote the software, you can promote this quantum technology among your peers. So you will get first-hand information from IBM quantum team. So this is very good opportunity. So this is the flow. So first, what you need to focus? You need to focus on challenges. So complete challenges and try to get a digital badge like this. Then focus on summer school. Once you completed these two, you can appear for certification. Okay. So once you clear this certification, you can appear for advocate post. After completing advocate post, you can focus on internship. So probably each and every one of us need to get internship. Either it could be a student, either it could be faculty. So getting internship will increase your higher ups. Okay. So once you completed this internship, it will happen for 3 months. So virtually you can do internship anywhere in this world. So this is one great flexibility from IBM Quantum team. So once you got a completed internship, you can act like a mentor. So normally for faculty, they are offering mentorship post. So through this post, you are able to get a very bright student across globe. Okay. So these are the free courses. So I recommend each and every one of you go through these free courses. So I recommend basics of quantum information. So this is very basic fundamental level. Once you're able to clear this course, you can focus on quantum safe encryption. Okay. So if you are interested in cryptography, you can focus on quantum safe encryption, then practical introduction to quantum safe cryptography. For this, you need basics of Python. So everything involved with Python. Okay, if you know Python, it is very easy to get with Qiskit. Okay, once you got familiar with all these courses, then you can go for variational algorithm design. So this is nothing but quantum machine learning. So if you want to use machine learning in quantum domain, you need to focus on variational algorithm design. So this is my suggestion. If you want to build your career in quantum, so follow these steps. So all these courses are free. I will share this link with you. So all of you able to see my screen, IBM Quantum screen? Is it visible for all?
Yes, sir.
Okay, sir. I'll share this hyperlink in text box. So go to this link. Go to this link if you are using desktop or laptop side by side. So look at there in top right. There is a option called sign into platform. So click this. Click this. I will log out. I will log out. So this is how screen appears for you, right? If you are using Gmail, use this option, continue with Google. So click this option, you're able to create account. You need to fill 3 to 4 pages, forms. Okay. So here your Gmail become your IBM ID. Once you created your login, you need to verify the authentication code from your Gmail account. Once you created your login, the dashboard will appear like this. So it will take 5 to 10 minutes time.
Please, sir.
So, shall we give 5 minutes for participants, or I can show demo? What we prefer, sir? Because we have very less time. This is recorded, sir. This meeting is recorded, right? Pavan, sir, shall we give time for participants, or shall I give demo? Later on, they can work on
Okay, sir.
what
Okay.
we plan.
Okay, sir.
We will give time, 5 minutes.
Yes, sir.
Okay, sir, you can. No problem is there.
Okay, okay.
Okay, sir.
So we will give 5 minutes time. After participants giving response, we will continue.
Okay, sir.
Demo
The
is enough.
participant can give the response on the chat also if they want.
Okay. So I will go with participants. I will show demo. So this is your dashboard. This is your dashboard, and you can see in bottom you can notice composer, IBM quantum composer. So click this composer, click this IBM quantum composer. It will appear like this. So are you able to observe a similar kind of environment? If you logged in, okay, if you click composer, okay, you will get the same kind of environment IDE. Anybody got? Okay, okay, great. Okay, great. So this composer will look like a musical note where you can drag and drop your quantum gates to create a quantum circuit. Okay, so if you observe these lines, so this you can consider like a physical wire. So individual wire. So Q0, Q1, Q2, Q3. So each and every wire are represents qubits, quantum bits. Okay. So beneath you can see C4. C4 stands for classical bit. Okay. How Q stands for quantum, C stands for classical. So this is normally like your register. Flip flop. Okay. Right. So for that, I want to cover the basics. Okay. So you can see Q sphere down left. You can see Q sphere. You can see state vector. Then you can see probabilities. Then you can see code editor. So this is the basic ID layout of Qiskit. So Qiskit stands for quantum. Qiskit stands for quantum information science toolkit. So this is a framework. So which is developed by IBM. Okay, we are using this framework in today's demo. So before that, I want to cover the fundamentals. So this is a block sphere which will act like a visualization tool. Okay, so this will give a better idea about visualization about a qubit. So qubit stands for quantum bit. Qubit stands for quantum bit. So what bit stands for? Bit stands for binary digit. Binary digit. So bit binary digit we are using two level system. two level system, either on or off. So this is the basic logic. Right. Here I can show. Cannot see. Once again. Okay. So here r equal to 1, radius equal to 1. Why we are making radius equal to 1? Because we need to do systematic. So this become unit sphere. So r equal to 1 means unit sphere. So radius will not go beyond 1 or below 1. So this will make your qubit stabilize. Okay. So this will make your qubit stabilize. So we are dividing this sphere into two halves. We are dividing this block sphere into two halves. Okay. One is northern hemisphere, one is southern hemisphere. Why we are dividing into two levels? Because we want to represent binary system. We want to represent binary system. So that is why we are representing in two levels. Right. Right. Then we are having this Cartesian axis XYZ, like normal mathematical three-dimensional axis. So it will generate Cartesian coordinates. It will generate Cartesian coordinates. Okay, you can observe 2 points, 2 dots in North Pole and South Pole. So this will act like polar points or extreme points. So this is state 0 and this is state 1. Maybe maybe I will hide this taskbar. It is not working properly. Yes. Now it is visible. Fine. So we have block sphere. Block sphere used to visualize your quantum bit. So, okay. So we divided that block sphere into two halves, northern hemisphere, southern hemisphere, because we need to represent binary logic. Then we are having two extreme points. One is North Pole, one is South Pole. So these points we able to represent state 0 and state 1. Okay. So these 2 points are called pure states, or you can say mixed states. Sorry, pure states. Pure states. Fine. Then take any arbitrary point in your block sphere. Observe this green dot. Observe this green dot. Okay, this is not working. Okay, observe this green dot. This green dot represents arbitrary point or random point. Okay, you are generating a vector from origin to that green point. So this is nothing but your electron. Okay, so consider this is your electron. This electron can revolve across your sphere anywhere, like revolving around nucleus, right? So this will give state vector. So this will give state vector. This vector will represent state vector, which is nothing but quantum state vector. Okay, so I will revise. So we have two hemisphere and we have extreme points, which is state 0 and state 1. We have random point. Look at the green dot. So this is called state vector. This blue color arrow is called state vector. Okay. So this point, what you call, it is mixed state. So this point and this point are called pure states. These are called pure states. So anywhere in your sphere, any point, it will represent mixed state, or you can say superposition. Superposition. Sir, are they covered superposition in previous section? Organizer sir, Pavan sir. In previous lecture, are they covered superposition, or I need to cover?
So in previous lecture, not covered.
I think little bit.
Little bit.
Little bit. Okay.
Yes. I think little bit he is covered. Okay.
So if it is not sure, I will go.
There is a message. You please cover from basics. Some participants are asking.
Yes, sir. I will
Thank
cover.
you, sir. Thank you so much.
Yes. Yes. Okay. I will cover from basics. No issue. Okay. So we will cover from basics. Quantum is based upon two fundamental principles. One is superposition and one is entanglement. Okay. So what is the meaning of superposition? One state over another state. One state over another state at same time. So this is the simplest definition I could provide for superposition. Okay. So if you have a thing, the thing can exist in multiple states. So one state over another state at the same time, it is called superposition. So for an example, if you are looking at an object by your naked eye, okay, so your eyesight is straight. Okay. So there is no superposition because you have single eyesight. Suppose if you are wearing goggles or if you are wearing spectacles, your vision is superimposed by your glass. Okay, now your vision is superimposed. Okay, suppose if you are wearing a 3D glass over your spectacles, now your vision is superimposed by your Google as well as 3D glass. So at the same time, you have different superimposed vision. Okay, this is the simplest example I can give. Same way, entanglement, it is a very strong correlation between two quantum particles. Okay. So take an example of a quantum particle. A quantum particle could be subatomic particle. A quantum particle could be subatomic particle. It could be photon. It could be electron. It could be ion. It could be any subatomic particle. So these particles will spread out like a wave. So normally when we are studying in school in chemistry, they will show electron like a dot. But electron will not appear like a dot. Actually, it will appear like a wave packet. It will appear like a wave packet. So electron can exist anywhere in this region. Anywhere in this region. So this is actual representation of electron. Okay. So electron will spread like a wave. Okay. If you want to know where it is located, you can take the help of probability. Suppose if you want to locate electron in this position, in this location, so what is the chance? 45%. 45% of chance to exactly locate the electron in this location. Suppose if your electron over here, then what is the probability? 30% chance. If your electron move over here, what is the chance? 20%. So it is very weird. Okay, because normally when we are studying chemistry, they will depict electron like a dot, but in actual phenomena, it will exist like a wave. Okay, very strong and strange phenomena. And a single electron can exist in multiple locations at same time with different probability. So take an example. So if you are pointing an electron can exist anywhere in that packlet, in that area, right? So a state of being in multiple location at a single time with each with different probability. So classically it will not happen. So if I am teaching over here in Bangalore, at the same time I cannot exist in Ghaziabad. At the same time I cannot exist in Mumbai. But for electron, it can exist multiple location simultaneously with different probability. Okay, this is the fundamental difference between classical thing and quantum thing, right? So if you want to know the full detail about an electron, you need to add all its possible states. So that is called superposition. Okay, a quantum particle can exist in multiple quantum states, and you need to add all its states together to find out superposition. So is this slide clear? So go slowly one by one. Try to observe how it looks like, how it behaves like. If you have any doubt, you can ask me, otherwise we can proceed. Is it clear, sir? Am I audible? Are you able to follow? Shall we move, sir? Anyone from participant?
Yes, sir, you are audible, sir.
Thank you, sir. Thank you. So we will have a simple example. If you are tossing a coin, okay, if you are tossing a coin contains two sides. So two sides, one side is head, one side is tail. So what is the chance of coin being hit in the air? What is the chance of being hit in middle of air, middle of the flip? What is the chance? Can you say what is the state of that coin during the flip? Are you able to say? Impossible, right? So coin contain two states. When it is flipping, when it is in air, 50% of chance being hit, 50% of chance being tail. So coin contains two phases equivalent to two states equally divided into two probabilities. So 50% chance for being hit.
This meeting is being recorded.
When you stop that coin by hand, or allow that coin to fall down, to settle down, then you can say 100% by looking at it. Okay, after it is settled down, 100% it will be showing to head, 100% it will showing to tail. Okay, so in the air it is in superposition. After falling down, 100% for head, 100% for tail. So here it will be or, here it will be and. Able to get the idea? So attach this logic to a Schrodinger cat experiment. So this is an experiment where we can keep black box. We cannot see what is in this box. Okay, it is opaque, and we are keeping a cat. We are keeping a radioactive material. Okay, we are closing that box. This radioactive material going to decay at some point. If it is decayed, cat become dead. If it is not decayed, cat become analyzed. So what is the chance for cat? 50% chance for being alive, 50% chance for being dead. So inside box, cat is in superposition. Cat is in superposition. Okay. Once you open box, 100% cat will be alive or 100% cat will be dead according to the situation. So this is a famous example for superposition. So these are classical analogy to understand quantum phenomena, even though it is not exact, but it will give idea how quantum works. So any doubt between these two examples? Shall we proceed? Are you able to follow? Shall we proceed, sir?
Yes, sir, you can proceed.
Yes, sir. Thank you. So increase complexity. Instead of 2 states, we are taking a cube. Cube contains 6 phases. 6 phases means 6 states. For some person, orange appear like a front face. For some person, blue appear like a front face. From which angle you are observing, you will get that illusion. Okay. So according to the observer, according to the angle, according to which side you are observing, that face, that color appear like front for you. Okay. So attach this principle to a electron. So consider electron like a cricket ball. So cricket ball can spin upwards. Sometimes it could spin downwards. If it is spinning upwards, associate with 0. If it is spinning downwards, associate with 1. So these are called quantum states. So normally how we are representing data in classical with the flow of electrons. But here we are using electron itself to store data and compute data. So fundamental difference. So sometimes cricket ball can spin diagonally. So if it is in diagonal, it is in superposition. So concept is very simple. So electron can spin upwards. If it is spinning upwards, attach that phenomena to represent stage 0. If electrons spinning in between, it is in superposition. So if it is tilted, it is in superposition. So we'll go back to the previous slide. I will cover from basics. Okay. So block sphere. So block sphere is a visualization tool to visualize qubit. So this this block sphere contains radius equal to 1 because unit radius. So unit radius means stabilize. We are dividing this block sphere into 2 halves to represent binary logic. Okay. So we are creating 3 axes XYZ Cartesian coordinate. Okay. We are taking 2 extreme points. These points are called stage 0 and stage 1. Okay, just like the previous example, consider this is like cricket ball. Okay, so these 2 polar points are called pure states, and we are taking 1 dot. This is your electron. This electron represents mixed state or superposition. It is in between 0 and 1. Okay, it is in between anywhere in your sphere. It could be superposition or mixed state. So we are dividing that sphere into a xy plane where it is intersecting, and we are doing projection. So this is not working. So here I will take laser pointer. So look at here, we are doing projection from this green dot to xy plane, right? Then what we are doing? We are doing a projection from that origin to this intersection, this violet line. So we have right angle triangle. So carefully observe. So we have right angle triangle. So once we got right angle triangle, we can apply trigonometry. To apply trigonometry, we are forming a right angle triangle. Okay. So next, it will form two angles between z-axis to your state vector and x-axis to your downside projection. Okay. So we got two angles. One is theta and one is psi. Okay. So these two angles will help you to convert Cartesian coordinate into polar forms. Okay. So now recall the school fundamental trigonometry functions mathematics. Okay. So this is your wave function. So this is your wave equation. Exactly, if you want to describe. So this psi is nothing but superposition state. Superposition state, or you can say quantum state. Okay. So apply deta equal to 0 over to this equation. Apply deta equal to 0. So this equation contains two components. One is sine part, one is cosine part. Okay. So cosine part related to state 0, sine part related to state 1. Okay. So recall the previous slide. So here the deta is angle formed between z-axis to state vector. Okay. If deta equal to 0, what happens? If deta equal to 0, where this vector will points? Are you able to follow my question? So deta is the angle between z-axis to your quantum state vector. If deta becomes 0, where it points? Shall I need to check the chat box? State 0, great. Great, Mr. Vineet. Sorry, I am not looking at your chats. Great. If deta equal to 0, it is pointing to state 0. So there is no angular difference. Okay. So apply deta equal to 0 in this equation, you will get cos 0 by 2 multiplied with state 0 plus a to the power I psi sine 0 by 2 multiplied with state 1. So here we are involving with complex number as well as negative number. That is why we have Euler form, right? So the whole component becomes 0. The sine component becomes 0. Okay. Only the cos component you will get 1 multiplied with state 0, you will get 0. So this is nothing but your identity gate. So this is nothing but your identity gate. So is it clear? Is it clear? Put in your chat box. If you apply deta equal to 0, great. So thanks for following. So next what we do, we apply deta equal to pi. Now tell me where it points. Deta equal to 0 means north pole. Deta equal to pi means great. So deta equal to pi means it will point to south pole. So whatever you do mathematically, you're able to visualize in quantum. So this is the power in quantum. If you want to understand mathematics, how it works, you can easily go with quantum, right? So apply d tackle to pi cos pi by 2 state 0 plus sin pi by 2 state 1, you'll get state 1. So this is nothing but 180-degree rotation. This is nothing but 180-degree rotation. Apply d tackle to pi from state 1, it will go back to state 0. So this is nothing but your NOT gate operation. Is it clear? Is it clear? Great. Okay, we will proceed. So now we are moving to next level. Apply d tackle to pi by 2. Now tell me where it goes. Apply d tackle to pi by 2. Now tell me where it goes. Visualize block sphere, your state 0 north pole, state 1 south pole. So pi by 2 means where it goes. Is it difficult? Very difficult to visualize? X-axis. Great answer. So it will go to equator. So 0 means state 0. Okay. Pi means state 1. Pi by 2 means exactly in equator, which is called equal superposition. Equal superposition. So 50-50 chance. 50% for state 0. Okay. 50% for state 1. So that is why it is called equal superposition. This operation is called Hadamard. Gate operation. So this is very important gate in quantum. So this will create a random number. This will create a random number. Okay, which is truly random. Which is truly random. So note down this point. Okay. So this is more than enough to understand qubit superposition, equal superposition. We will do hence. So all of you look at this dashboard. So this is your dashboard. Click go to file, click new. So go to view, enable panels, enable all panels. It will look like this. Okay. So what we do, we will disable all these views for better understanding. Go to view, go to panels, disable code editor, disable code editor. Disable code editor, go to view, go to panels, disable probabilities, go to view, otherwise you will keep probabilities. Okay. What I do, I try to delete quantum bits. So click Q0, click this bin button. Okay. Click Q0, click bin button, click Q0, click bin button. Keep only one qubit, Q0. Do same thing for C4. So C4 stands for 4 classical bit. So click this, select minus, click this, select minus, click this, select minus, rearrange your view. So do like this. If you're able to follow, just follow. Otherwise, you can observe simply. No issue. Okay. So we discussed stage 0 in previous example slide. It is not pointing. Close the No, it is not working. 1 second. So to teach quantum, to learn quantum, we need to have multiple graphical tools. Yeah. Stage 0, we'll change color. This is stage 0. So all qubit by default initialized or prepared to stage 0. So note down this point in Qiskit, when you create any qubit, by default it is initialized or prepared to stage 0. So that is why we have this fuse here. This electron is pointing to north pole, stage 0. Are you able to observe? Because the circuit is empty, if you create any quantum bit, you will get stage 0 position. Okay, so you can look at the top right. This is called phase disk. So move your mouse over this phase disk, you will get quick output. So real part 0, imaginary part 0, probability of state 1 is 0% because the qubit is initialized to stage 0. Okay, so look at state vector. Okay, the signal strength of stage 0 is full 1.0. See, in quantum, everything is manipulated and controlled by signals. Okay, so that is why we have y-axis in amplitude terms. So this represents signal strength of stage 0. Because circuit is empty, this full signal is showing to 0. Okay, we have one qubit. How many possibilities we have? Either 0 or 1. Okay, so that is why we have two computational bases in x-axis. You able to observe 0, 1. So in probability, it will show stage 0, 100%. So in my login, it is not showing. There is a software glitch. But if you are looking at your tool, it may show correct output. Anybody getting stage 0, 100% probability in your login? Check, please check and tell me. So look at the probability, whether it is showing to 0, downside. No? Okay, fine. Maybe software glitch. Look at here. So this is a cross, right? What you do is we have NOT gate. So this NOT gate will flip state 0 into state 1. State 1. So this is nothing but the current will flow. So it is like a switch. If you switch on, current will flow through this wire. So that is why you got output in blue color. Now you can see changes over here. Probability of state 1 is 100%. Probability of state 1 is 100% because we implemented NOT gate which changed state 0 into state 1. You can see in Q sphere. Now it is pointing to south pole. Now it is pointing to south pole. Because we applied NOT gate from 0 to 1, it is flipped. So in state vector also, signal strength now showing for 1 full 1.0. Now it is shifted, right? Now look at the probability. The probability of state 1 is 100% now. Previously it is not shown, right? But you can recheck. Are you able to follow? So put in your chat box. Just refresh, drag and drop NOT gate. Okay, great, great, great. So what we do, you select this NOT gate. Okay, press delete button. Press delete button. Are you able to see changes in your graphs? Now it is pointing to North Pole. So amplitude is showing 0 full strength. Probability of getting value 0, 100%. Okay. If you have any doubt, you can ask me until this. Are you able to understand the NOT gate? Great. No doubt means great. So what we do, we drag and drop NOT gate. Now it is pointing to South Pole. Again drag and drop NOT gate. Now you can see changes. Okay. So initially stage 0, NOT gate. So this is one NOT gate. So now it is changed to state 1. Current is flowing. Okay. Now again we are applying one more NOT gate. Again it will turn into 0. So two NOT gate will cancel each other. Cancel each other. That is why we got original state. That is why we got original state. If you applying two NOT gate next to next, will cancel each other. Okay. So delete this NOT gate. Delete this NOT gate. Now look at one more important gate, what we discussed in superposition slide, Hadamard gate. So I try to highlight Hadamard gate. Okay. So what you do, drag and drop the Hadamard gate, this red color gate over Q0. Now look at your output, how it is changed. This Q sphere pointing stage 0, state 1 at the same time, which is an example for superposition. So a single qubit can represent both stage 0, state 1 at same time, which is not possible in classical. In classical, either you can represent 0, either you can represent 1, not at the same time. But in quantum, you are able to represent both information at the same time. Okay. So look at the state vector. The amplitude is divided into 0.7 for 0, 0.707 for state 1. Look at the probability. To get value 0, you have 100% probability. To get value 1, you have, 50% probability, 50-50. Because it is in superposition. Okay, if you try to measure, you'll get only one value, like binary classical value. So what it means, if you implement Hadamard gate, it will create 0 for 50% of time, 1 for 50% of time. So this is what it means. So this will generate a random value between 0 and 1. So this is random in nature. So if you want to generate random number, this Hadamard gate will help you. Suppose if you are running this circuit for 100 times, so 49 times you will get 0, and 51 times you will get 1. So this will change each and every time. This percentage will change each and every time. So normally 50-50 chance for 0 and 1. So that is why at the same time it will show 0 and 1. So any doubt you can ask me. Clear? Great. So we'll move. So delete this Hadamard gate. Delete this Hadamard gate. We try to increase the complexity. So click Q0, press plus button. Now 2 quantum bits created. Same way click C1. Click C1. Click plus symbol. You have 2 classical bits. Now we observe the difference between the previous one and this one. We have 4 different possible combination: 0, 0, 0, 1, 1, 0, 1, 1 for 2 qubits. Okay. Now recall the previous slide. So Q0 initialized to stage 0, Q1 initialized to stage 0. What is the output you got? Stage 0 as well as stage 0. That is where you got 0, 0. So this 0 represents the rightmost 0. This 0 represents the leftmost 0. Are you able to get the idea? Could you explain one more once Hadamard gate? Okay. Okay, I will explain. So I'll delete one qubit. We'll go to the previous example. So drag and drop Hadamard gate. What it will do, it will represent both stage 0, stage 1 at the same time. If you are running the circuit, this Hadamard gate will produce 0 for some time, 0 for some time, 1 for some time. So this occurrence will be random. It is like rolling a dice. Okay, you will get random value for every throw. Same idea. If you have Hadamard gate, okay, either it will produce 0, either it will produce 1 randomly. So this is what it means. You cannot predict what it generates. So this is true random number generation. If you use Hadamard gate, it will introduce randomness in your qubit. So one more definition I can throw. So Hadamard gate will introduce randomness in your qubit. It is like throwing a coin. If you are throwing a coin, what you are doing, you are creating randomness through that coin. Okay. Suppose if you want to do measurement, okay, if you are tossing a coin, if you want to stop that coin by your hand, then you are doing measurement. Okay, I'll explain that concept. So here you can notice a gauge which is called measurement. So what we do, we drag and drop this measurement gate after Hadamard. Now you able to see, look at your output, drag and drop this Hadamard. Now your superposition state got collapsed. You'll get only one output for stage 0. For some other user, you will get state 1. So it will be random. Are you able to do this exercise? After Hadamard gate, drag and drop a measurement gate. It is like a gauge. You can get from the left side. Okay, in third row, the fourth one. What happens if we cascade to Hadamard gate? Great question. Okay. Drag and drop two Hadamard gate, which will cancel each other, which will go to original state. Very nice question. So stage 0, Hadamard gate, it will create equal superposition. Again, if you are implementing Hadamard gate, which will cancel each other, which will bring back to original state. Like two NOT gates. Like two NOT gates cancel each other. Two Hadamard gate will cancel each other. Is it clear? Okay. Very nice observation. I appreciate it. So go back to the next example. 2 qubits. We are dealing with 2 qubits. If you have 2 qubits, you have 4 different possible combinations: 0, 0, 0, 1, 1, 0, 1, 1. Okay. So to understand this circuit, what we do? We try to implement NOT gate in Q0. Try to implement NOT gate in Q0. Now try to understand the circuit. Stage 0 initially. After NOT gate, what will you get? State 1. State 1 is nothing but switching on your switch. You're doing switch on. So switch on means current will flow. So that is why you got state 1. Okay. The second qubit is empty. So no current will flow. That is why state 0. So as we discussed, Q0 represents the rightmost bit 1. Q1 represents the leftmost bit 0. So in Qiskit, you need to remember this representation, little tricky. So topmost qubit represents the rightmost bit. The bottommost qubit represents the leftmost bit. So is it clear? Shall we move? Getting one is okay. Each and everyone will get a different answer because it is random. Okay. It is random. Now what you do? Drag and drop this NOT gate to Q1. Observe the changes. Observe the changes. Now Q0 always becomes 0. Q1 always become 1. So look at the first possibility 0, 0, which is not possible because Q1 is always 1. Always 1. So this is not possible. Look at 0, 1. Q0 is always 0. So this combination is not possible. Okay. So look at the third one. Q0 is 0. So this is satisfied. Q1 is 1. So this is also satisfied. So this combination work out. Look at the fourth combination. Q0 is 0, but here it is 1, which is not possible. So this is how you need to understand your circuit and your output. If you have any doubt in this example, you can ask me. Clear? Are you able to follow for 0, 1? Okay. Then what we do? We drag and drop one more NOT gate in Q0. Now observe the changes. Now both qubits are 1. That is why it is pointing to south pole. 1, 1. Now probability also shifted to 1, 1. Okay. Now select these NOT gates, delete. Select these NOT gates, delete. Now circuit is empty, 0, 0. What do you do? Try to drag and drop Hadamard gate in Q0. Hadamard gate in Q0. Now recall the previous example. This will create 1, 0 simultaneously, randomly. Sometimes it will create 0 for Q0. Sometime it will generate 1 for Q0. So 2 possibility for Q0. So 0 and 1. But for Q1 always stays 0. So that is why this component become always 0. If you understand this, you can understand the upcoming examples. Clear? Okay, great. Now what do you do? Implement a NOT gate in Q1. Implement a NOT gate in Q1. Observe the changes. Observe the changes. So what you'll get for Q0? You'll get 0 sometimes. You'll get 1 sometimes. Q1 always state 1. Always state 1. That is why 0, 0. So 0 is possible for Q0, but 0 is not possible for Q1. Always 1. So first combination is not possible. Look at the second one. 1 is possible for Q0. 1 is possible, but 0 is not possible for Q1 because Q1 always 1. So this combination is not possible. Look at the third combination. 0 is possible for Q0. So this is possible. 1 is possible for Q1. This is possible. So both combinations are possible. Okay. So look at the fourth. 1 is possible for Q0. Okay. So 1 is possible for Q1. So this also possible. This is also possible. So what we will delete this NOT gate, drag and drop one more Hadamard gate and see what happens. This is phenomenal. Within 2 qubits, you are able to represent 4 possible combination simultaneously. At same time, you can do computation, you can get a result also. This is not possible in classical because it will take 4 seconds. But in quantum, within single seconds, you are able to represent all possible data, all possible computation at the same time. Now amplitude reduced to 0.5. Observe over here. Okay, probability divided into 25%. If you add, you will get 100%. If you have any doubt in this example, you can ask me because it will take some time for some participant to understand. So this is called superposition. We applied superposition for both qubits. Enable all possible combination. Very much clear. Thank you. Thank you so much. What we do, we try to do measurement. So apply measurement gate in Q0. Now look at your circuit, Q0 and Q1. Oh my God. Are you getting the same error or only for me? Problem is coming. Okay, no issue. They are updating, unfortunately. Okay, no issue. What we do, we will explore that platform. Oh, everything they are updating. Sorry about that. Okay. IBM Biscuit certification. I'll- So if you want to become IBM Qiskit certificate developer, you need to go to this link, share in chat box. So check your chat box. I share this link. So it will lead to this page where you can find all information about IBM Quantum Qiskit certification. So they will give a certification overview, followed by key area of competency, what you require, recommended skills, what is the exam objective. Everything is very clear, and you can take assessment exam, and you can do sample test and study guide. Everything they gave in this web page. And this exam contains 60 questions, and you need to score 44. Okay, you need to get correct answer for 44 questions. So exam time is 1.5 hours, and they will give each and every topic with percentage. So importance of each and every topic they gave. So entire syllabus they gave. Okay, so you can go for exam resources. So here you can find syllabus, right? So online lab, what we did so far. Okay, and they gave presentation study guide. Everything is there. Okay, so if you are appearing from UK, this exam cost $100. Applying from India, sorry, if you are applying from US, exam is $200. From India, only $100. Around 8,000 to 12,000, it will vary. Okay, so I will share one resource if you want to study for this certification. So I follow this website. Go to this website. You will have very clear instruction, step by step. So they will start from NOT gate, okay, OR gate, AND gate, NAND gate, whatever we studied in classical. They will explain very beautifully. Okay, they will give Python code also. So whatever we did in GUI mode, we are able to do through coding. So it is very simple Python code. You can learn within 1 or 2 days this syntax. Okay, what we discussed, they showed step by step. Okay, go to this page, and I like to introduce IBM Qiskit advocates, where you can find more number of people who are working for IBM Qiskit community throughout the globe. Throughout the globe. And you can find me under Asia tab. So you can find me under Asia tab, Bangalore, India. So likewise, once you clear the certification, they will list out your name in this web page. So you will get global recognition, and if there is any event, they will sponsor you across the globe. Okay, this is very good opportunity for you. So please focus on certification, promote this certification among your student. From India, only 120 people clear this certification. So there is so much of demand for this certification. Then what I can show, I can tell IBM quantum use cases. You might ask where we can apply this quantum, which field, which technology it will get benefit. So I'll share this link with you. So go to this website. You have some idea. IBM Quantum Educator website is not there. You need to apply for that program. Okay. You need to check with the IBM Quantum team. You check that web page. Somewhere you can find. Now they are updating. I don't know where they put. That is the problem. So in CERN in Switzerland, they are using for particle accelerator. For Boeing, they are using chemical industry, Mercedes-Benz, petroleum industry, pharmaceutical industry. Everywhere they are using. Okay, so this will give a very good idea where you can apply this quantum use cases. So if you have any doubt, you can ask me. Unfortunately, the tool is not working. So I can open for question. So unmute yourself, you can ask. So if you have any doubt, if you want any information, you can connect with me with my social media ID. You can unmute and you can interact, no issue. We have a lot of time. Thank you all.
Sir?
Yep.
Yeah, if suppose I want to prepare for that certification, Quizzkit certification, how much time it will take? Probably, I'm asking to prepare for the exam.
Ma'am, I prepare for 5 months. It's up to you. If you are fully focused, like laser focused, you can clear within 4 or 5 months.
Okay, sir. Okay. Yes, sir. Thank you, sir. Very nice session, sir.
Thank you, ma'am. So you can apply quantum for machine learning, artificial intelligence, natural language processing, quantum communication, quantum teleportation. The uh, applications are n-fold. It is not limited. Computation is only fractional part. Step to have composer in IBM website. After logged in, you go to composer. You can scroll your dashboard. It will come down. You need to select composer. Once you click composer, you can click new. If you click new circuit will come. Okay, then you need to go for panels. If you go for panels, you can change your view. Okay, what are the ID you want, you can enable and disable. This is your question, Atal 089. Yes, thank you. Anyway, the recordings are available with organizer. They will share you. You can go and recheck. You can revise this video. And I want to share one more link with you to do self-study, because 1.5 hour we cannot touch each and everything. Quizzkit YouTube channel. I will share this link with you. Please go through it. So in our lifetime, we cannot complete this YouTube channel. Lot of playlists are there. Go and explore slowly, one by one. Okay, each and every video will consume your time. You need to stop that video. You need to take some time, go for Google, then come back, do research, then come back. Okay, so thank you all. If you have any question, you can ask me. Otherwise, we can wind up.
Good evening, sir. Sir,
Yes, ma'am.
my question is that I want to do my research work in quantum computing. So
Okay,
I
ma'am.
wanted to ask you that when I have the data set and I want to work
Mm-hmm.
in security. Okay,
Okay.
so how since I haven't started yet, so
Okay.
can you guide me how can I start?
Yes, ma'am. Once you're logged in, you can see the dashboard. From the dashboard, scroll down. You can see lot of courses, free courses provided by IBM Quantum. So I suggest every one of you to go through basics of quantum information. Once you complete that course, then you can easily go for quantum safe cryptography. So directly, if you want to go quantum cryptography, it will be very difficult for every one of you. So to understand quantum, it will take 3 to 4 months, maybe 6 months. So once you got strong foundation, then you can go for quantum cryptography. So everything is based upon Python. So everything they abstracted. Now, if you know Python, if you know Qiskit, basics of that course, you can proceed very easily. Each and every step they will give tutorial and code sniffer.
Sir, and like if I want to detect malware, like I want to work in cyber fraud detection of transaction. Okay, so
Then we can go for quantum machine learning, ma'am.
sir, and if I want to do by using quantum, so what
Okay,
changes will be there, and what
okay,
will be
okay.
the benefit of using quantum particularly in this field?
Great, great, great. So normally, if you are transfer any information, binary information, we can duplicate that information infinite times. Suppose if you have value 0, you can duplicate that value 0 in any number of flip-flops or registers. But in quantum, you never able to copy a quantum information. Suppose if you want to copy, once you try that attempt, that superposition information got collapsed. That quantum information going to lose. This is the beauty of quantum. If anybody want to hack any quantum data, okay, immediately that information will get lost. So nobody can hack quantum system or quantum information. If they try to do, the whole information will get lost. We know what happened, but in classical nobody know. If they are duplicating data, we don't know what is happening. If somebody is snipping our data, we don't know. But in quantum, it is impossible. So that is why
Okay, sir.
dealing with quantum data with quantum security is highly effective.
Okay, sir. Thank you very much. And sir, your session was great.
Thank you, ma'am. I try to touch up. Very difficult to touch up with 1.5 hour.
Sir, please share your LinkedIn ID.
Yes, ma'am. I already shared. Once again, I will share. YouTube link also I will share one more time. You just Google, it will come. If you want to deal in QML, you need to understand how first quantum works. Then only you need to focus on quantum machine learning. So it is entirely depends upon your problem. Not all problems are suitable. If your problem is very hard, very complex, it involves with a random number or random guess, meta heuristic problem or combinatorial problem, then you can go for quantum machine learning. Otherwise we should not go for quantum machine learning. So choosing a problem is very important in quantum. Really, if it is not solvable by your classical computer, then we need to think for quantum conversion. So normally quantum data sets are very limited. We are taking classical data, we are converting into quantum version by using encoding technique. Great question, by the way. Pawan sir, shall we wind up if there is
Yes,
no
sir.
further
Yes.
question?
Yes, sir. Thank you so much, sir, Dr. Jayakumar, sir, for such an engaging and informative session. Your step-by-step guidance
Thank you so much.
on QSKIT and practical demonstrations have given us a clear understanding how to utilize quantum simulators effectively. This session truly bridges the gap between
Thank you.
theoretical knowledge and practical application. We deeply appreciate your time and effort in providing us with such valuable insights. The knowledge gained today will undoubtedly be a strong foundation for further exploration in quantum programming and simulations. A big thank you to all the participants for your active engagement and enthusiasm throughout the session. Your questions and interactions added great value to this learning experience. Before we wrap up, a gentle reminder to kindly fill out the feedback form for this session available in the chat box. Your feedback is crucial to us and help us improve future sessions. Thank you so much, sir. Jay Kumar, sir.
Thank you so much, sir. Thank you for all participants patiently
Thank you,
listening
sir. Thank you,
until
sir.
9 o'clock. Thank you,
Very
thank
nice
you, thank
session,
you, sir.
sir.
Thank you.
Okay, Pawan, sir. We
Thank you
can
so
wind
much,
up now.
sir.
Okay, good night.
Participants, please fill the feedback form available in chat box.